Black and yellow, black and yellow, black and yellow. Oh, yeah, so today is 8-3, Solving Right Triangles. The title in our book is Trigonometry. Trigonometry. So our objective is to use trigonometric ratios to find angle measures in right triangles and to solve real world problems. Sounds fun. Alright, so in San Francisco, it's famous for its steep streets. We often have a percent grade. The steepest street has a 31.5% grade. That means it goes it rises 31.5 feet over a horizontal distance of 100 feet, which is equivalent to a 17.5 degree angle. How the heck do you get that? Well, actually, you can use trigonometric ratios to change a percent grade to an angle measure. So that's just an example of where it's used in the real world, and we'll get to the ideas. So you can see this might be something you will definitely want to copy down. SOHCAHTOA, SOHCAHTOA. Remember that. SOHCAHTOA, SOHCAHTOA. So we have sine of B equals opposite over hypotenuse. Cosine B equals adjacent over hypotenuse, and tangent of B equals opposite over adjacent. Now I'll go through more with you guys that this is cosine. For now, just get the ideas down. And you heard me say SOHCAHTOA. That's because it's S-O-H, so, C-A-H, ka, T-O-A, TOA. And you can see kind of what's going on in each of these. Sine of this angle is the opposite side over the hypotenuse. Cosine of this angle is the adjacent leg over the hypotenuse. See that above? And then tangent, let's see, it's opposite over adjacent. So it's the opposite leg over the adjacent leg, and we'll have numbers for these. And let's pause to go to a quick little video here.
Yeah, you know what it is. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Yeah, you know what it is. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Yeah, you know what it is. When I'm doing math, I do it big. Yeah, screaming that's nothing. When I'm doing math, that's stunning.
Oh,
When you see me in the class doing math, put it down from.
Alright, we're done with that. Alright, so back to the slide. You could listen to those sick rhymes right down here. We have example 1. So we're going to use the trigonometric ratio cosine A equals 24 over 25 to determine which angle of the triangle is angle A. So let's see. If we do cosine of angle 1, that's SOHCAHTOA. So C-A-H. So cosine is adjacent, the 1.4 feet, over the hypotenuse, 5 feet. So let's set that up. We'll get something like 7 over 25. You could calculate that as a decimal. And then how about cosine of angle 2? Let's see. Adjacent here, adjacent to the angle next to, divided by the hypotenuse, 5. You get 4.8 over 5, which comes out to 24 over 25. So therefore, which one, angle 1 or angle 2? Since cosine of angle A is this, and cosine of angle 2 is that, then they're the same thing. Good, so you could see we're going to go through the same idea here. I will skip that one. I'll leave it up so you could kind of look at that. Tangent, similar thing. So how about tan of A equals 1.875? If I do tan of angle 1, TOA, TOA, TOA. So that's tangent of angle 1 is opposite, so the 27, divided by the adjacent, 4.5, 4.4. And we got 1.875. So that is going to be the one that's equal to angle A. Good. Alright, and let me just say this chapter is this section is pretty in-depth, so just do your best and you could come to questions with class tomorrow. To class tomorrow, with your class. Alright, so far we know sine of 30 might be 0.5. Now if we want to go in a backwards process, we could do inverse sine of 0.5 would equal 30 degrees. And that's all on your calculator. Here's what we mean. Let's say we had to find the measure of angle A. We did not have that. So we don't have angle A here. Well, you could kind of get this to the other side. And when you get it to the other side, it's going to be inverse sine. Inverse sine is how you describe that. Kind of like you have to get things, it's the opposite when you get it to the other side. So same thing here, same thing with tangent. Alright, so you could use your calculator to calculate this. If you have trouble with this, I will help you tomorrow in class. Here's some examples. So inverse cosine of 0.87 is 30 degrees. Here we get 58, and here we get 35. Alright, so next we're going to use everything to find everything. Just little by little, literally find everything, man. And where's Waldo? Where is Waldo? You could find that. Yeah. Alright, so here, I'll show you this problem, yeah. So we want to find all the angle measurements and then all the side measurements. First off, it's a right triangle, so we know we could use Pythagorean theorem. A squared plus B squared equals C squared. And we're missing this side, so you do that. You get 2.74. And then next, we want to find angle R right here. Well, let's see. We know angle R, the cosine of angle R, is adjacent leg over the hypotenuse. So again, we could set that up. All right, cosine of angle R equals this over this. Then we want to get cosine to the other side. You could see that being done right here. And calculate that. You get 29 degrees for angle R. What does angle T have to be? 90, 29, and blank. 61 degrees. Excellent. So I'll just put these up. I know this video is a bit long, so I will put these up. There's multiple ways you could kind of go about this, but there's the answer there. And I'll keep these up. We'll kind of go through more examples tomorrow. Bring your questions to class, and I will be happy, very happy to go through this with you. Lots of real world stuff here. So have a wonderful day, and I will see you tomorrow.